Hello, this is Marin Ailey, and I would like to welcome you to the RightStart Math online conference that we're having today, featuring Dr. Joan Cotter, who will be presenting RightStart Math, the past and the future. Joan worked as an engineer and taught her 3 children at home before and after school and during summer vacations. To help them learn their arithmetic, she devised card games that were published in her first book, The Math Card Games, 300 Games for Learning and Enjoying Math. After starting a Montessori preschool, Joan taught in several Montessori schools and incorporated Suzuki violin and piano. She also taught mathematics in grades 6 through 8 and worked with children with special needs. Dr. Cotter designed the double-sided Cotter AL Abacus and wrote RightStart Mathematics, a comprehensive elementary and middle school mathematics program that incorporates visualization, the Cotter AL Abacus, math card games, and the drawing board tools. The RightStart curriculum is an outgrowth of her doctoral research. Dr. Cotter speaks at conferences across the U.S. and worldwide. We do ask that you hold any questions until the end of her presentation, please. And with that, I give you Dr. Cotter.
Thank you, Marin. Welcome to Hutchinson, Minnesota, where the temperature is now 92, which is warm for Minnesota. I want to start with my math journey. By 3rd grade is the first time I can remember anything mathematical. We were learning the multiplication facts, and it was considered cheating to learn any facts that we hadn't had in school yet. I still think that's kind of amusing. In grade 4, sorry about this.
We had it for a second, so if you need to step on the purple and then hit there you go. Now we see your grade 3.
Okay, grade 4. Oh, in grade 4, I was going to a parochial school, and the title of our math book had arithmetic in it, and the title of the public school math book had mathematics. And I thought mathematics sounded much more exciting than arithmetic. I didn't realize that arithmetic was a branch of mathematics. In grade 5, I came up with number puzzles. At that time in Wisconsin, where I grew up, license plates had 4 digits on each license plate. And I loved to, as cars went by, to see if I couldn't make an equation out of it. And that's the source of the number puzzles. When I was older, I would, on a walk, I'd even try to see if I couldn't get the number puzzle done as I walked from house to house. I usually made it. In grade 6, we were studying fractions. And one day the teacher mentioned about turning fractions into decimals by dividing. I was absolutely astounded. I couldn't believe it. I had no idea that fractions were related to division. And that teacher, in order to keep us up to date on our fractions, every day she would write 2 fractions on the board. And at the beginning of class, we were to add them, subtract them, multiply them, and divide them. And of course, without any context, there's no way you could tell whether your answer made any sense. So obviously, my math in the early years was strictly rote. In grade 7, I happened to look at the back of the book. There was an appendix in my math book. And in one of the appendices, it had check numbers. They're also called, I can't remember some other names for them, but they have other names. And I thought that was really fascinating. So I mastered them, and I showed my brothers. I have twin brothers a year younger than I am. In 8th grade, our mother had us do multivides. Now that's my name for that mathematical activity where you start with a number multiplied by 2, then 3, then 4, all the way down to 9, then you divide by 2, 3, so on, all the way down to 9. And my brothers and I got really good at multiplying and dividing by doing those, and we enjoyed doing them. Yesterday, I called my sister, who's 20 years younger than me, asking her if she did any multivides. And she knew what they were because she taught her children RightStart math. But no, she said, our mother did not teach her. And to this day, I do not know where my mother got that idea from multivides. I have been looking in old arithmetic books, well, for decades, and cannot find any other place where anybody else ever did it. And since she's gone, I can't find out where did those multivides come from. It's a mystery. Also, when I was in 8th grade, I wrote a paper, a research paper. I think we could write it on anything we wanted, on the math and music, how an octave is exactly twice as much, has twice the frequency. And the teacher, when she gave my paper back, had very little notes on it. I now know why. She did not understand what I was talking about. 9th grade. 9th grade is when I really became interested in math, algebra. And the reason is Miss Habermel, my very nearsighted teacher, on every Friday would write the assignments for the next week. And I loved to spend my weekend to see if I couldn't get all the assignments done before Monday morning. I rarely made it, but I had a lot of fun trying it. But more importantly, I learned how to read a math textbook, which really made a huge difference in my life. Also in 9th grade, I discovered crisscross multiplying, where you could multiply a couple numbers without writing anything down except the answer. And I was just devastated a couple of years later when I found that process explained in a book in the library. I thought I was doing something original. Also, back in those days, we had to know how to do square roots by paper and pencil. No, I couldn't do it today. But as a 9th grader, I figured out a paper and pencil way of finding a cube root and impressed my teacher. 10th grade, that was a tough year for me because I was diagnosed with rheumatic fever, which meant I spent 10 months in bed. I was diagnosed right before Christmas, which meant I had to finish up the year by myself. And since I was past 8th grade, the school was not required to send anybody to my home to help me. My parents were unable to help me. My mother did not reveal to us children, actually I didn't find out till just a few years ago, that she never graduated from high school. They actually moved to Madison, Wisconsin, so we kids could go to the university there. Remember, there were 3 of us within 2 years. So thinking about the cost of going to college, my parents thought way ahead. So I finished up the geometry course, and if I had a question, I had to write it out, have my parents mail it, and wait for the answer to come back, because I took the courses by correspondence. I learned not to ask questions. Also, I was so enthralled with that geometry that I made a little booklet of geometric designs. I wish I had that today, but it's gone. In 11th grade, I could only take 2 classes at school. I had to come home before lunch, not much time for socializing. And the science classes were on the 3rd floor. I could not climb stairs. And they did not have an elevator that I could use. So I could not take any science. So I took chemistry by correspondence, and I loved it. Now, of course, there's no lab. And my dad happened to see an ad in an industrial magazine saying that they had a little booklet that you could send for explaining to students what an engineer was and what they did. So my dad ordered one for my brother, not for me, for my brother. And I still remember that afternoon, I was sitting there reading that booklet, and I decided right then and there, I was going to be a chemical engineer. Well, 12th grade, I was able to go to school full time, and I took physics. So that was my very first science class with a lab. I had no science classes whatsoever in grade school. And science was not taught in my grade school. And I decided to do electrical engineering because it uses more math. As a college freshman, I was the only woman in my class out of 300 electrical engineers. Actually, for the 4 years of engineering school, I had a woman instructor for only 60 minutes. One day, an economics instructor was was missing, so a woman substituted for him. And that was the only time, 60 minutes out of 4 years, that I had a woman instructor. So I really had no role models. And I had never even talked to an engineer before I decided to go into engineering. One course I had to take as a freshman was mechanical drawing. That's where I use a T-square and slide rule. Now, I was at a disadvantage because in those days, in junior high, at least in Wisconsin, all the girls had to take home ec. We had to learn how to cook and how to sew. Actually, the sewing machine I had to use was a treadle, believe it or not. But the guys took mechanical drawing. So they already knew the basics, and I didn't have a clue, but I managed. Also, keep in mind, there were no computers in those days, no calculators. Instead, we had to use a slide rule. And I still have my handy dandy slide rule, and it cost $20. Now, this was back quite a few years. So today they'd be several $100s. But you cannot add or subtract on a slide rule. And the middle part's supposed to move. They're made out of bamboo, and you constantly had to adjust them. This one obviously is working too tight. So they can multiply. Also with the slide rule, it did not give you a decimal point. You always had to figure out your decimal point. It could do square roots and exponents and all kinds of things. After I was through, one more thing. When I was a junior in college, I took the very first computer course ever offered at Madison, University of Wisconsin-Madison. And I was since I was the only woman in the class, I am the first woman to ever take a computer course at the university. And today, that's one of the most common majors is computers. After I was through school and had a couple of children, my neighbor asked me if I would tutor her son, Tom. And my family, we grew up playing a game called Contact. And actually, and I wanted to play that with Tom because it was a game. There are three numbers on each piece. And each piece is a different color. So you had to match the color, and they had to total 5, 10, 15, or 20. Sounds familiar? Well, I tried to buy a game like that to play with Tom, the boy I was tutoring, and I couldn't find any. Finally, I called the company, and they said they weren't making it anymore. So I decided to make it my own game. So I made up corners, which has 4 sides to it. And at first I did not use color because, well, it was all made by hand. And I made them out of file folders. And I put triangles around the numbers on the top and squares around the number on the side and a circle around the other number. And you had to match the circle as well as the number. And we made the original game, Contact, was an adult game. And there's some rules in it that did not work for children. Kathleen actually came up with the idea of always having 4 cards. The original game, you wanted to get rid of cards as fast as you could, or pieces, I should say. You wanted to get rid of pieces as fast as you could, and you had a penalty if you had any left over. Well, children don't like to subtract it from their score. So she came up with the idea of always having 4 cards. And the original game also had 3 hands. You had to play it 3 times and add your score. Children don't want to do that. They want to know each time what their answer is. So I used that basic idea, but greatly changed it. Then I became a Montessori teacher. I read about Montessori in the newspaper one day when Kathleen was 3, but there was no Montessori training centers in the state of Minnesota. The closest one was in Chicago, which is 300 miles away. Not very helpful when you have 3 young children at home. But some of the things I learned from Montessori is that young children are very capable. Actually, I kind of believe that because I was one of those big sisters that liked to teach my younger brothers and sisters. In fact, I have a brother, Tom, and Tom says that I taught him everything In fact, his teacher at school, and when he was in kindergarten, said they couldn't teach him anything more because I had already taught him everything. He knew how to do cursive writing before he started school. They were amazed what he knew, all because I was having a lot of fun teaching. But I was too shy to even think about being a teacher, so I didn't go into teaching. So one of the insights is young children are very capable. They can do a lot more. In those days, it was almost a crime to teach a child to read or to do any math before they were in first grade. In fact, people used to say that's going to damage their eyes if you try and teach them to read. You think about a baby crawling. They love to look at the little crumbs. They don't mind looking at little tiny things. Also, Montessori really taught me how children learn and how to break things up into small pieces, in small steps, so they can master topics. Suzuki does the same thing. In fact, when you're learning a piece of music with Suzuki, the first thing you learn about the piece is the hard part. You practice the hard part. And then when you're learning to tackle the whole piece, you already know the hard part. So then you can do the whole thing. And I like to say that Montessori gave me the ability to understand how children learn, while engineering gave me the background to know how math is used in the real world. So those two really, really go together. Now, Montessori in other ways greatly influenced RightStart Math. One thing is Montessori liked to use colored rods, and we're from our colored beads. And the colored rods came from one of our competitors, came from Montessori's colored bead bars. But Montessori also had a set of what she called the black and white bead stars. And my instructor, Mr. Yostin, said Montessori devised that black and white bead stairs so the children didn't have to count. And I really remembered that. So the children didn't have to count. That's what we should be doing. Also, when you take Montessori training, at least the type that I did, one of the first things we do is make a geometry book. And I actually took my drawing board and tools and showed the rest of my classmates how to use a drawing board to make their geometry pieces. It's a lot easier than the way they were doing it. One other thing, Montessori uses a bead frame, which you can see pictured there. But all the beads are the same color in each row. And we dutifully learn how to add on it, how to subtract, how to multiply. But you can't do division, I was told. You can't do division. Montessori even has that in one of her books. You cannot do division on the bead frame. Well, I thought, if you can multiply, you can certainly divide, right? So I proceeded to figure out how to do division on the bead frame 2 different ways, and went back and told my instructor, and he started teaching that. Now, the Cotter abacus history. The early abacuses that I made this is one of my early ones. Notice the frame is actually an oak picture frame. But some of the frames that you bought were not exactly square, which didn't work too well with beads. And notice the gap between the 5th and the 6th row. I didn't have the idea of reversing it. And I did not use bright, distinctive colors. I didn't think it was necessary. Because remember, I'm coming off of Montessori's bead frame where the whole color is the same row. And then one day, I had a German girl in my class, and I had been to Germany before that, and I saw an abacus in one of the toy stores there. So when my German mother went back to Germany for the summer, I asked her if she would go to that store and buy one of those abacuses. So she did, and it looked just all the beads were reversed. I'm sorry, they did not reverse. They were blue and red. So there were 5 blue all the way down, all 10 rows, and then 5 red. And she started telling me, she said, and there was another abacus there and I stopped listening to her, and I got a light bulb and said, that's what I'm going to do is reverse the color. Now, whether she actually said that, I don't know, because I stopped listening. But maybe she's the one that prompted that. I don't know. So I made the first 200 abacuses in my kitchen. I ordered the beads. And now this is this is in the day before there was any internet. So even finding companies that make beads was not easy. I had to go to a large library and look up. There's something called Thomas Manufacturing Books, and I had to scour through them to find a company that would make them, and then call them and find out they make the kind of beads I know, and ask them to send me their catalog. So it was a difficult process. And then the wires, they came in long pieces, 36, and I used a wire cutter. I could get 4 out of each piece, but then there was a little piece left over when I would cut that last little piece that was flying around the kitchen. So I used one of my husband's, one of his old shoes, so that's to keep from having that little piece embedded in the ceiling. And what I did to finish the wood on them, I would put the wire, two wires in, third from the top and a third from the bottom, and then I would hold on to those. And then I was able to turn the abacus around back and forth to finish both sides. And then to allow it to dry, since I had done both sides, I took egg cartons and cut them in half and then put them over the egg carton. So that was how I made about 200 abacuses. Finally, they got to be too many. And we found somebody in China who would make them. And their quality wasn't what we needed. So we went to North Dakota. And actually, once we switched to North Dakota, I appeared on television in North Dakota, explaining that we were having them made in North Dakota. It was a big deal in Minot. Also, I want to mention about the Wreck and Wreck, as they look like our abacuses. And I was in Utrecht, the Netherlands, where they had a huge room of all their manipulatives. And at that time, the Wreck and Wreck only had 2 rows. And I told them that they should have all 10 rows. Today they do. And they were allied to the University of Wisconsin at that time. And I suspect, I'm not certain, that's the reason the beads are red and white. Because red and white are Wisconsin's colors. One little interesting thing about Utrecht, the 4th graders do their math with fountain pens. And when they have something wrong, they just neatly cross it out and continue on. Now, the drawing board and tools, where that came from. Kathleen and Connie, when they were 7 and 8, my daughters, I introduced them to the drawing board and T-square, and they made some designs, but the equipment is way too big. I mean, the board is 2 feet long for a 7 and 8-year-old. That's way too big. But Connie decided to become a mechanical engineer, and she, of course, had to take mechanical drawing. But instead of using the big tools like I had to use, they had small sets. So I said, Connie, when you're through with your tools, could I borrow them and try them out with my Montessori children, the kindergartners? And they absolutely loved it. And as you've seen the picture in the book where 6-year-old Stephanie divided an equilateral triangle into 256 parts. Incidentally, today, she is an oncologist, radiologist at Mayo Clinic. She's one of my success stories. She also finished up when she was finished with 1st grade, she had finished up 3rd grade math at another school. So the children in my Montessori class did very well. I had one girl skip 1st grade. I had another boy skip 2nd grade. One day, the principal of a neighboring school came over and wanted to watch the children. And the children, I'll admit it, they started showing off. Some of them started playing the game that takes adding and multiplying. Another group was playing a game with fractions. Now, these are kindergartners. This was in the era in which kindergarten was strictly play. teachers didn't teach them anything beyond counting to 10. And they certainly weren't taught anything about the sound, about how to read. The history of the geometry panels, that came from Alice Chalmers, the maker of those orange tractors. And they had an education department at that time. And their panels they were not either in inches or in metric. I'm not sure what the designer had in mind, but that's what got us started on doing those. Fractions, I have to credit Catherine Stern, Dr. Catherine Stern. She was born in Poland, which is originally part of Germany, and she came over as a refugee. She was part Jewish, and never mentioned that she had a Montessori background, because the attitude towards Montessori at that time was very negative. So she did a lot with math, and I'm greatly influenced by her. She's the one that devised the fraction chart. And when Andy went to a special school, and parents were encouraged to come in and help teach, and I ended up teaching fractions to all the kids in that school. And I did it through card games. I started making up games. And Andy's teacher, Royce Andrews, suggested that I write a book on math card games. So in one summer, I wrote that book, 300 card games. And I had to do it on a typewriter. And to make the pictures of the cards to show how to play them, I used a piece of cardboard and cut out a little rectangle and then traced that on the paper, and then typed the numbers and then cut them out and pasted them on top. So it was a long, long procedure, but I got it all done in one summer. During my career as a Montessori teacher, I spent 1 year teaching children with learning disabilities. And that was when I kind of started with the Abacus, but I had developed so little that I didn't even leave the Abacus for the next teacher. In my other classrooms, the children played the card games. And as the other classrooms, actually in White Bear Lake, I developed side 2 of the Cotter AL Abacus. And the children were going on to the public school first grades, and I kept getting phone calls. My child is bored in first grade. What should I do? So I realized that what I was doing wasn't benefiting very many people. It was making things harder for the children. So I said, I have to get some more degrees, because engineering and Montessori equals 0 as far as the education community is concerned. So I went and got my master's. And I did 3 things when I got my master's. Within 1 year, I went from teaching 4-year-olds to teaching junior high. The first thing I had to do, I had to get a math major. In order to be certified to teach high school math, you have to have a math major. So a math major is not the same math as an engineer. I'll take engineering math any day. It's much more practical. We actually had to take a course, a geometry course. In fact, quite a few people dropped it and never completed their schooling, in which parallel lines meet. And the instructor was not very helpful. So I taught junior high math for 3 years. And the biggest thing I learned from that is that when kids don't understand math, it's hopeless. It's very hard for them to do anything in advance. I actually had a boy that said, what's the use of learning how to find area? You're never going to need that. Well, you ever going to paint a wall or buy carpeting or roofing? And then I also got the actual degree is in curriculum and instruction. And the big thing I learned there is how long it takes to write curriculum. In the course, the specialized course on that, I only got 3 lessons written, and I was just so devastated I couldn't get more. The instructor wasn't surprised. I think part of the reason to show that it's a long procedure. It's not easy. Well, after I had my master's, I was teaching a course at the local community college, and someone raised her hand and said, "Do you know about the Mache homeschool show in Minnesota?" Actually, it was the other end of the cities. I said, "No." It was 2 weeks away. So I applied. Kathleen quickly made a table cover for us. I tried to figure out what we would need, and I'm off to my first homeschool show in 1987. And while I was there, I met a woman from Illinois. She invited me to do the Illinois show. It was shortly the same year. I actually stayed at her house. And that was really traumatic for me because that meant I had to drive 300 miles. And I had never done long distance driving before because I couldn't stay awake when I'm driving. So I figured out the way to stay awake is to eat constantly. And the math kit that we sold in those days consisted of 4 items. The activities for the Abacus book, and that's what it was called then, worksheets for that book, the drawing board with tools, and I made a little booklet out of it, and the math card games kit, which included the Abacus. And I didn't feel quite right. I thought there should be more math there, but I didn't have anything more at that time. But people were very happy to get it. But then I went back and worked on my PhD dissertation. And I did my research in first grade classrooms. One classroom was doing essentially RightStart, and the other classroom was doing traditional math. So I wrote all the lessons for the teacher. It took till April. I thought I'd be done a lot sooner. And at the end of the year, the school, every class was graded. The students who were learned this way did significantly better than the other classroom. So that school asked me to continue writing. So everyone thought I would do second grade the next year. Well, it didn't make sense doing second grade when you think about it, because half the kids did not have RightStart. So that'd be pretty hard. So I did kindergarten instead, and then continued, then did second grade and third grade and fourth grade. And by the time I finished fourth grade, I said, I don't want to ever write another lesson again. I've had it. Because every day I had to get one done every day. And then the teachers wanted me to get a week ahead of them. So that was difficult. And back in those days, one time, Al and I wanted to drive out to California in an E85 vehicle. Al was a director for corn growers at that time. So I would write the lessons when I'm sitting in the back seat of the car. And then when I get to the destination, I would fax them back to the teacher. Things were kind of primitive in those days. And the very first school, other than the one where I did the original research, was in Virginia. And that's when the name RightStart became official. I do not remember the origin of the name. So actually, the RightStart math, how it was written, I first did kindergarten. Well, I revised first grade at the same time I did kindergarten. And then I did grades 2, 3, and 4. And I was also speaking quite often at math conferences and homeschool conferences. And I'd often teach a course on how to do the drawing board tools. And I was starting to get questions, well, what comes next? And in the back of my mind, I was thinking, there's really a lot of math you can teach using these tools. So finally I said, all right, I think I'll write level G. And it took 4 years. In fact, we actually just quit. I actually have a couple more lessons that never got in the book. One was really cool, where you make a geodesic dome that doesn't fall apart. But it never got in the book and never finished it. And then we did the second edition because I wanted to update things. And then also the second edition has two columns. One column is what the actual teaching, the other is the explanation. And I got that idea from my advisor. That's the way he he did some work on fractions. So we now go from level A through H. So what's the purpose of RightStart Math? I think our mission statement states it beautifully, helping everyone understand, apply, and enjoy mathematics. I truly believe that mathematics is one of God's gifts to us, and it is wrong to make someone dislike it. And the reason people dislike it is the way they are taught. And I'm trying to do my best to change that in this world. What is the future? Well, there's a new book coming out that's going to explain a lot of these math things that I've been talking about, and even some things that aren't in the book. And also, nothing makes me happier than to see the success of our students. And Tobias is one of them. He actually is the one that does 3D printing and makes those holders for the place value cards and the other cards. And he's finished 1 year of aerospace engineering, and he is now interning in California on working on F-61 jets. And he gives credit to RightStart Math. Incidentally, when I talked to my sister yesterday, asking her about the multivides, even though she is the only student in her class that took calculus in high school, she told me that she didn't really understand basic arithmetic until she taught RightStart to her children. So I'm now ready for questions.
You can go ahead and either put them in the chat box or just go ahead and unmute yourself and start talking if you have any questions.
Well, thank you, Dr. Cotter, for sharing all of this. This has been absolutely fascinating to hear where RightStart came from, and not just from the idea of, oh, this is where you started it, but this is going all the way back to your third grade and how that changed and shaped and developed RightStart Math.
Well, it's been a pleasure talking to you.
Well, you do have a question. What would you recommend for a parent who is not good at math at all?
Well, if you have the time, and if you're a parent, that means you don't have the time. But if you did, it might be nice to go to your local community and simply take a math course. But otherwise, teaching your children starting at level A, you will learn a lot of it yourself. Because that's one of my goals, is to teach you as well as your child. I'm teaching you how to teach your child. And that's why there's that right column to explain why you do this or why you do that. Does that answer the question?
Yes.
Okay.
Any other questions? All right, the next one. I have some friends considering a 1 or 2 day a week hybrid homeschool co-op. How many students would you think is ideal for a classroom?
Well, I like to work with children, three or four in a group. But if you got older children, with some can play the games while you work with the others. Actually, in my Montessori classroom, now the children were ages three through 6. I had one person, an assistant, and she did no teaching. So I'm teaching 24 children, and I worked with groups of usually 3 or 4. And I taught them everything from how to tie their shoelaces to how to divide on the abacus. I was very busy, but I did it.
We had another comment from Debbie that I wasn't good at math until I started teaching RightStart to my children, and I'm so thankful. Another question from Gina. We have used many of the curriculums before using RightStart Math with my child with autism and ADHD. This curriculum helped her to understand and remember the math facts. So thank you. So I guess not a question, but a statement.
Oh, thank you.
And Laura is asking, are there any student aha moments that stick out?
Oh, let's see. That's a tough one.
You have the one, Joan, about the little boy with the fractions and he was leaving. And he thought he
Oh,
knew everything.
yes. Oh, yes. Oh, yes. Michael. Michael had learning disabilities. He was a third grader, and that time they didn't teach any fractions before third grade. So I was spending 45 minutes a day tutoring him, and he was leaving the area. So on the last day, I had him put the fraction puzzle together, and I asked him those questions, you know, how many fours make a whole and all those kinds of things. And at the end, I said, now, Michael, don't think you know everything to know about fractions, because we have not done something like 1/4 plus 1/8. He did it in his head, came up with the answer 3/8. This is a child who had never had anything with fractions before and had learning disabilities.
That's awesome.
Yes, obviously I was impressed because I still remember the story.
Any other questions? All right, Joan, do you have any closing remarks?
Not really. I'm very thankful for everyone who's helped, all the people who work at the RightStart, whether in Hazleton, North Dakota, or around the country or the world. And we all have to keep working. This is becoming really critical. We need more people who have a background in math. It is so sad when people cannot pursue the career they want to because they don't know the math. And I've met many people like that. And I'm hoping there'll be fewer of those in the future.
All right, we do have one more comment from Carrie. I was pretty good at math in school, but as I'm teaching my girls RightStart, I feel like I'm learning a new language, which is overwhelming sometimes, but I'm seeing my girls grow so quickly that I believe this is going to be worth it.
Thank you. Yes, you do have to keep persevering. Mathematics is something we have to work at. And being frustrated sometimes is perfectly normal and natural. You were never frustrated. You're not going to learn anything. I mean, can you think of anything that you've mastered that you didn't have some frustrating moments? Think about cooking. Did you ever have a flop? Think about learning an instrument. Sometimes it's difficult, but that's life. So you just have to persevere and keep at it. And sometimes the very best thing to do is walk away and come back a little while later and tackle it again.
And Rachel has a comment. We are thankful for you,
Well,
as all of us are.
Well, thank you.
All right. Well, thank you everyone for taking the time, and thank you, Dr. Cotter, for joining us today.
Thank you.